Welcome to our program for learning Java Enterprise Applications Development. We'll start with Java 7 language course, followed by some advanced level courses on different frameworks and technologies which can be used to develop Java Enterprise applications. Let's get started with Java 7. In this course, we'll cover the core features of Java language by using a textbook titled as Starting Out with Java 6, written by Tony Gaitis. In the second half of the course, we will be covering the exam objectives for professional certification from Oracle Certification for Java Associates. We'll cover each one of those exam objectives so that at the end of the course, if you decide you can write the exam for Oracle Certification for Java Associates. On the last day of this course, we will conduct a mock-up exam for OCJA. And we encourage all of the students to write the certification exam as it is well respected and looks good on your resume. This will help you to find jobs in IT industry. Let's get started. As you can see that the name of the exam is Oracle Certified Associates for Java. And the exam number is 1Z0-803. When the time comes, you can go onto the Oracle website, register for the exam, and you can take this exam by going to the nearest Prometric Center. Let's take a look on these exam objectives. Although they seem a bit out of the scope at this time, but these are the exam objectives, which obviously we'll cover one by one in the second portion. But anyway, they will be covered during the first half as well, as all of these exam objectives relate to the core features of Java language. So there is in fact no separation between these objectives, which we will be doing in the second half, and what we will be doing during the first half. However, the two textbooks separately concentrate on both of these portions of the course. So here is the course information. The two textbooks that we'll be using, starting out with Java 6, written by Tony Gaitis, that is for the first half of the course, and the second book, written by Oracle Press, is for the second half of the course and is helpful for writing OCJA exam. The development environment that we will be using is Dr. Java, or if you decide you can write code in Eclipse. My name is Muhammad Azam and I will be your course instructor. My contact information is listed here just in case if you need to get in touch with me and if you have any question. Here is the course website where all the course materials, including video lectures and the other class notes, will be posted. This course will have a TA who will be available from Monday to Friday for 2 hours. His hours will be posted on the course website later this week. So let's get started. And here is the Java program Lifecycle. But before that, we'll take a look. Why do people learn programming? What is this programming all about? And how does it all work? I encourage you to watch this interesting film that will provide you incentives why you should learn programming. But I'm not going to play this right now, as you can have this PowerPoint presentation in the course folder, and you can watch this video when you get this PowerPoint presentation. Let's take a look on this now. So, how does it all work? A computer basically is a combination of hardware and software. What we mean by hardware is illustrated in the course notes. The collection of physical elements that constitute a computer system are called hardware. Anything that physically exists and makes part of the computer is called the computer hardware. For example, keyboard is hardware, mouse is hardware, the monitor is an output device and it is the hardware. And inside the computer, there's the motherboard and then there's the CPU. That is called the brain of the computer. And then there are memory areas. One is the primary memory of the computer, which is called RAM. And then there are other portions of the computer, which you all might know already. But those all pieces get together in order to perform what the computer is supposed to do. But those parts alone can do nothing until there is code that is written. And that code, in fact, coordinates efforts by all these parts by sending them signals. And that code is what is called the software of the computer. So software is essentially code that is written and is used to coordinate all these components inside a computer system. So here is what is the definition of that operating system. If software that manages computer hardware components, software resources, and is responsible for carrying out essential services for proper functioning of a computer is called the operating system. So operating system in other terms is also called a software because it doesn't physically exist, as opposed to the hardware, which means that the components which physically exist. So this combination of the operating system and the hardware, that is what makes up our computer. And once we have a computer system, then we write application softwares to perform certain specific tasks. So if we want to define an application software, an application program is a computer program designed to perform a group of coordinated functions. Tasks are activities for the benefit of the user. It is more like a tool. Every application software is a tool that is used to perform certain specific activity. Just like a plumber uses his tools, this is probably the most generic tool which is capable of producing any kind of tool that we might want to use for a specific industry. For example, an application software is written for flying planes. So inside the plane, there is a flight simulator that coordinates efforts of different components and different parts of the plane and provides functionality for successful flights. So that is a software, or it is an application software for that specific industry. But look at spreadsheets. They provide solution to perform certain tasks for the people, those who are in accounting or want to make analysis of data. Microsoft Word is used to perform different operations in offices. So that is an application software. Look at browser. Browser is used to read different pages from websites. It is used to send emails, receive emails, and all these social networking sites. All of these make use of a application software, what is called the browser. And we use a language to develop that application software. So By now, I hope that you have understood that an application software is written using a language, what is called a programming language. And these application softwares are used by different industries. You name it, like agricultural industry might use softwares or application softwares to assist them with their work, like aviation industry and all these other industries and different walks of life. They have application software to help them within their domain. And as the software developers or programmer, this is our job to get information about requirements of the different people, those who want to perform certain specific activities. And we write those applications based on their requirements and based on their logic of business. And then that application software will help them to do the work they intend to do. And in order to write those application softwares, we use a programming language. In early programming languages were like C, COBOL, Fortran, Pascal. Like all these languages were procedural languages. Why we call them procedural languages is because they heavily depended on procedures or what we call routines or subroutines. Think of a doctor who is operating in the operation theater. He is performing a procedure on patient. But while he is performing a procedure on the patient, he might call another procedure from the nurse. So nurse will call her or his assistant. Maybe that assistant will perform a procedure, will bring up a tray of different tools, will hand it over to nurse. Nurse will perform the procedure she is supposed to do with whatever arrangements or things she is supposed to do. She will do it, and then the doctor will be able to perform the procedure after nurse has finished. So you see that here one procedure calls another procedure and another procedure calls yet another procedure. So this is the mechanism or the modus operandi behind procedural languages. But what really makes them tough to work with is the separation of these procedures from the data on which these procedures work. It is the same data. In this case, in this example, it's the same patient upon which the doctor was performing the procedure, and then the nurse was performing the procedure, and then the assistant of the nurse was performing the procedure. So the same data is transferred from one procedure to another procedure. And as a programmer, this passing data from one procedure to another procedure and to another procedure, that was difficult. And now we have different set of languages which are called the object-oriented languages. So in object-oriented languages, that separation of data from the procedure is gone. Now the data has become part of those objects. For example, if you take a look on this diagram, here you can see that this procedure 1, here this procedure 1 is passing the parameters. Parameters mean it is passing that data to procedure 2. And now from procedure 2 to procedure 3, the same data is being passed. And here at the lower end, you can see that data is passed from procedure to procedure. But in object-oriented programming, that data is part of what we call object. So think of a person as an object. In this concept of object-oriented languages, there are actions and then there are attributes. The data is part of that object in the form of an attribute. For example, if a person is 6 feet high, his height is 6 feet, that is data. It is saved as an attribute of that object. And actions which that human can perform, move, run, sleep, go, come, all these actions are called the operations. And the data is called the attribute. And all that culminates into one entity, and that entity is called an object. So there is no distinction between data and the procedure. That distinction is gone in object-oriented programming. So here, that tedious task of passing data from one procedure to another is gone. So this is all about objects, because now the data is hidden. The data is not visible to other objects. It is hidden, and here this is done with the help of a concept called encapsulation. During our course, we'll discuss objects in great detail, but for now, this is the difference that you should keep in mind. What is the difference between procedural languages and object-oriented languages is that in procedural languages, the language depended heavily on procedures which will operate on central pool of data, and when procedure 1 calls another procedure, the same shared pool of data was shared and the data was passed from one procedure to another. And as a programmer, this was difficult to pass data from one procedure to another, but in object-oriented programming, we make data as part of the object and it's hidden. That is not separate from those procedures anymore. So this is what is called the object-oriented programming, and Java is object-oriented programming. Now let's take a look at brief history of Java. For brief history of Java, in 1991, Sun Microsystems, a company, they tasked a team to devise a star 7. Star 7, what they meant was a device. A device that will be able to manage different home appliances. So with this device, they wanted to operate different home appliances. Well, this team was called the Green Team. James Gosling was the lead of the project. This project overall failed because each one of these devices was independent of the other. So the principle what this team had in mind, or the objective what they had in mind, was what is called the VORA, means write once, run anywhere. So they wanted to have this star 7 device which could be used to turn TV on, which could also be used to turn off another machine, another home appliance. Well, this project failed, but at the end, they thought that, especially the team lead, the James Gosling, had an idea that what could work in this case. So if he could somehow translate the given source code written in whatever language they were considering to use into something intermediate like something that could be interpreted and understood by all these devices, then this could work. And as a result, he came up with an idea of a programming language called Oak, which will compile in intermediate code that was based on Vora principle. So this intermediate code could be interpreted by every device the same way. So this intermediate code was the success that Java has gained. And we'll discuss it in more great detail, how this intermediate language will help us write code once and we should be able to run it on different devices. And with this Oak language, they built a browser called the Hot Java, was a web browser, and that was later adopted in 1995, I believe, was adopted by Netscape, and the story went on. And now the Oracle has the ownership of Java, and the current version of Java is 8. So that's it for now in this video. We'll see you in the next video. We'll continue this discussion from the next video.